Now we're going to look at how we describe quantitative data. That's where we're using meaningful numbers for our data. We're going to start with talking about histograms. A histogram is very similar to a bar graph, but the horizontal axis is a number line. So now essentially our categories are numbers, and the bars touch each other. So let's just look at an example of how this works. A teacher records scores on a 20-point quiz for the 30 students in his class. And the scores are here, 19, 20, 18, blah, 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 all these wonderful numbers. Now, if we want to present that information, what we'll do is we'll take our data and essentially create categories, and the categories are numbers. Okay, so here we've got our graph, and our categories are the numbers, and so our scores. So down here, and so this bar here represents people that scored 0. And then the next one would be scored at 1, scored 2, scored 3, 4, 5. And the height then is the frequency of that. So looking back at our data here, okay, notice we're looking at zeros. There are 2 zeros here, okay, and that is represented down here by, for 0, we have a bar of height 2, okay. And we go through in this, we just do our bar for each category, and they're touching because, well, there's just no possible value between 19 and 20 for these scores. And but our categories here are numbers. They are ordered, and they do, in a sense, touch each other. And so a histogram is really just a bar graph where the bars are touching, but the categories are actually numbers. Now, the number line, the histogram, does not have to be built over individual numbers. We can actually create categories out of ranges of numbers, and these are called class intervals. So class intervals are groupings of the data, groupings of the numbers. And the way we'll define them is we want to make sure each interval is equal in size, and we don't want to have too many classes or too few. And so usually between 5 and 20. And this all kind of depends on what the data is that we're looking at. And so we just kind of look at the range of our numbers and decide how many classes we want. And then by taking that range of numbers and dividing by how many classes, that gives us an idea of how big our class intervals should be. So let's look at an example then with these class intervals. Suppose we've collected weights from 100 male subjects as part of a nutrition study. For our weight data, we have values ranging from a low of 121 pounds to a high of 263 pounds, which gives a total span of 142, and we'd get that by just subtracting, taking the biggest number minus the smallest. We've got 142, and we decide how many intervals we would like to, or how many class intervals we want. And so, say we want 7, then we take this 142 and divide it by 7. And that gives us a number close to 20, okay? Or if we wanted 14 intervals, we take 142 and divide it by 14. That gives us a number close to 10. So that would be the length of the interval, okay? So you can just kind of try them out, try out different numbers of how many class intervals you want, and then decide kind of from there. And in fact, using computer software, you can quickly go through and see what different class interval sizes and numbers would look like. We're going to use an interval width of 15 here. And so we're going to start at the lowest number we want. Because our lowest is 121, we're just going to round that down to 120 so we can work with some even numbers. Okay, so 120 is the lowest number in our interval. And because we want a class interval width of 15, that means the lower bound of the next interval should be 15 higher than that. Okay, so we add 15, add the class interval width to get the lower bounds on each of the intervals. Okay, and then you get, of course, you don't want your intervals to overlap. And so if this is a 135, then the previous one will end at 134. Okay, and then we have our frequency table here from our data. So this tells us that we had 4 males of weight between 120 and 134, 14 between 135 and 149, and so on. Now we can create a histogram based on this. So we're going to go ahead and do that. Remember, a histogram was just kind of like a bar graph, so we'll start with our axes, and we have our ranges now as the on the horizontal axis, and so we've got our 120 to 134. So 120 to 134. And I'll go ahead and put a tick there to indicate the right end of that. And then we've got 135 to 149. And then 150 to 164. And then we've got our vertical axis. And again, we're going to kind of want our highest to be kind of the highest here. And looks like our highest here is 28. So maybe we go up to 30. Okay, up to 30. And then kind of separate this based on that. So let's go ahead and divide it into maybe thirds there. So we've got 10, 20, 30. So 5, 15, 25. Okay. And then we're going to create our bars from our frequencies. And again, now these bars are going to touch. So from our 120 to 134, okay, I've got my height of 4. Okay. And then 135 to 149, I've got a height of 14. Okay, and then the next one, I've got a height of 16. And a height of 28. And then 12. And you'll notice here, because my writing is not perfect, there's a little bit of variability between our widths. Of course, they are all supposed to be the exact same width. But, get as close as you can, and you should be good. Okay, this one's up at 8. And then this next one's at 7. And then 6. And then 2. And 3. Okay, so there's an example of a histogram.